What's going on, everyone? Welcome back to Better Biomed. Folks, today's going to be a good day. We are going to go through electronics theory in Arduino, probably to a level that you've never gone through before. And mind you, absolutely none of this is scripted. We're really just going to shoot from the hip here. And that's because I've got a pretty wide variety of experience with Arduino recently. In other words, I haven't been doing this for years like some people have, but I have been doing it for the last 6 months or so, pretty heavily, and trying to see where the limits are. And mind you guys, I have done zero coding, no coding. And unlike what used to have to be, people would go through and they would take other people's code and maybe modify it a little bit, but usually copy and paste. We're not going to do that. In fact, we might run through a whole entire project right here today after we cover like what exactly Arduino is and electronic theory in general, because they do kind of go one in one. But maybe we'll do a project after that just to see how easy this really is, right? And it is easier now than ever because of the stupid thing called artificial intelligence. Yeah, guys, I have a wide variety of projects that I've done, and I have done absolutely no coding for them. Although I used to, back in the 90s, I used to do a lot of coding with like BASIC. It was Visual Basic, Turbo Pascal, and C back in the day. And I haven't done coding in like 30 years. And I am able to make some of the craziest things. And yesterday, my biggest project yet was tested and it functioned flawlessly, but it wasn't a smooth road, okay? That's the one thing. A lot of people think, oh yeah, it's gonna be easy. There is a lot of thinking that has to go along with it. So first off, what you need to do, you need to start with a plan, okay? Whatever your project is, whatever your concept is, try to plan out as much as possible on a sheet of paper or on a document. Try to do as much written down as possible, because going through later and making modifications and changes could break the project, okay? And it probably will break the project, in fact. But we'll talk about that a little bit later as well. Just be mindful. You want to write down the concept of what you need or what you want. And from there, you're going to select what type of Arduino that you're going to use. And you're going to also you're going to figure out what kind of sensors you're going to want and what type of wiring you're going to need. All that's going to stem. And mind you, AI will help you with that. But just start with the concept of what you're trying to achieve and write down as much as possible. That means the menus that you're going to need, the type of things that your device is going to detect or interact with. All this has to be written down. Trust me, I have not always done that. And thus, I have run into some heartaches later on. And it's very expensive in time and having to go through and rewire a project or something because you started off with perhaps the wrong Arduino, right? It does happen, okay? So anyway, let's go ahead and let's talk about what the heck is this Arduino. It is not a buzzword, guys. Arduino is a company, okay? It's a company. And Arduino makes something called a microcontroller. And the microprocessor, microcontroller, you give it instructions like, if this happens, I want you then to do this. That's an if-then statement, right? So you basically tell it what you want it to do, and based on what it sees and what it measures, etc., it's going to achieve whatever it is you wanted it to achieve. So that's basically it. And that's why I told you, write down what you're trying to achieve in the beginning, because that way there, when you first present your plan to the AI, if it's most of the way written down or almost all the way written down, AI can figure out a lot of the details, and from there, you're just wiring. You're just following instructions and wiring it up. So it's pretty simple, guys. All right. Let's go ahead and mute that bad boy. My phone is right here. So I got two different areas right here where I can monitor questions. So guys, if you have questions, go ahead and I'll be watching them as we go so we can talk about this. That's what we're here for. It's absolute shit weather outside. And I've got my automated greenhouse right here. I can't install it because who the hell would install an automated greenhouse system when it's freezing rain outside? So I'm here with you guys. Since we're a captive audience, let's just talk about this. I want this to be more of a conversation than more of a lecture. So please, if you guys have questions and whatnot, go ahead and write them in the comments and we'll try and cover it. And if it's something I haven't thought of or something I didn't know it could do, let's go over it right now, okay? All right, guys, so let's go ahead and let's talk about Arduino itself. All right, and of course, there we go, jeez. Okay, so what is Arduino? And the reason I brought this page up is because it defines it so much better than I could. It is, or was, Arduino recently got bought out. Arduino is an open source electronics platform based on an easy to use hardware and software, okay? And it is widely adopted. There are millions of Arduinos out there of different types. And I keep saying Arduinos because that's the industry like generic term, kind of like Band-Aid. They're just microcontrollers, okay? And some of the best ones out there are not made by Arduino. Fact. Okay, some of them are like ESP32. They can run CNC machines and stuff like that, and it's just a little $30 chip. Okay, Arduinos are very inexpensive. They're very inexpensive. The base level, I've got a few of them over here, is like the Nano. It's like 20 bucks, right? And the ESP32s, you can get them for like $15 to $18. And they have more features than Arduino, like Wi-Fi, so that you can control or remotely monitor whatever it is that your project is. I mean, think about it. You can remotely control or monitor whatever it is you think. That's how cool this is, okay? So it is open source hardware and software. It is free. If you want to download the Arduino programming interface, the programming environment, it is absolutely free. You can go and download it today and you can start practicing. So anyway, Arduino, they all have some pretty common things, and that's why I'm going through this website right here, is because we are going to talk about some of the stuff that you should find on an Arduino, okay? Okay, so first off, you have your microprocessor, right? It's going to do all the brain functions. We have a crystal that keeps timing for the memory and for the microcontroller. We have a USB connector, right? USB is how we program it and possibly how we exchange data with it, either download it as packets or live view what the project's doing. You can do that. Voltage regulation and power supply. That's this whole entire section down here, okay? There are multiple ways of getting power into an Arduino, okay? And this is going to be very important because we're going to talk about power in just a little bit, because I have projects here that run off AA batteries, okay, for weeks. So Arduino is very low energy consumption. So if you want to power it with solar power or AA batteries or something, you can do that. And that's how cool this is. There are some roadblocks though, all right? So the power supply section is going to define your voltage rails, and it's going to regulate the power. And there's usually like a wide variety of power that you can put into these. Like, I think it's 5 volts or 3.3 volts up to like 12, sometimes higher voltage. And it will automatically, using an internal buck converter, it will clip the voltage at only what it needs. All right, so it's going to establish a 3 volt, 3.3 volt rail that powers the CPU, and a 5 volt rail, which is pretty much for all your sensors and stuff, okay? So one of the things that we need to cover, okay? Guys, there is CMOS logic and there's TTL logic, okay? Now, there are different logic levels, and this is something that you guys really should just know from your electronics courses. There are 3.3 volt and there's 5 volt, okay? And that means that even things like your relays, they're either going to be TTL or CMOS voltage levels for activating those relays. And that's going to be very important because if you want your project to run off of something like AA batteries, getting 5 volts out of AA batteries, which are 1.5 volts each, is not easy, okay? You got to use something like this where I've got a whole bunch of them, like 6 of them, in series, okay? So you need to understand that there's different voltages. There's 5 volt and 3.3 volt logic level. One of the most important things that you need to understand is your voltages, okay? I power most of my things off of switch mode power supplies, like this guy right here. And that is extremely dangerous because you could technically blow things up if you bump this or inadvertently power it on with it cranked all the way up or something. So be mindful of that. However, these switch mode power supplies that are variable mean that I can do all sorts of things, including troubleshooting, very quickly and very easily. So that's why I use them. And this is a contained environment. Nobody's going to come in here and booger up my stuff, okay? All right, so the power supply is a very important thing. When we talk about microelectronics and when we talk about switching things, remember there's 3 volt and there's 5 volt, okay? 3.3 volt and 5 volt. Sometimes, depending on your situation, you can use the Uno to switch things, right? Switch it like on or off. Sometimes the Uno has to trigger something like a transistor, okay? Because the Uno can't switch that much. It's a little baby, you know? But it is very good at switching MOSFETs, and it is very good at switching transistors if you need higher voltage and higher current, okay? So voltages, very important, understand that. There's 2 main voltages. I run 3 rails on mine, so I've got 3 volts, 12 volts, that's the stuff. And then I got the 5 volts, okay? We'll talk about that in a moment. Okay, the other thing that you are gonna have on Arduinos, you see up here, we have these pins called digital IOs. And down here, we have analog. It's A0 through A5. Up here, the pins are labeled D1, D2, D3, D4. And when you go through later, and later on when we talk about the pin out that we get from the AI, it says here, wire this wire to this pin, it's going to say like A1, A0, D1, D23, okay? So that means digital pins, analog pins. Now what you guys should understand for digital is it's either on or it's off. Analog, it's a wide variety, right? It could be 1.2 volts, it could be 0.39 volts, and using things like temperature and humidity sensors and stuff, sometimes those use analog because temperature is analog, right? It's not all on, it's not all off. Some days it's 72 degrees and some days it's 21 degrees, right? Yeah. So, pressure sensors, a lot of sensors are going to be analog, but then again, a lot of newer sensors are going to be digital. And they're going to use something called I2C or I2C, and it's like a programming language, or it's not a programming language. It's a language for communicating, kind of like RS-232, which is serial communications, which USB and the RS-232 ports, they use serial communications. Well, you can also get like 2-wire serial, but we can get 1 wire, and that's UART. So you're going to hear that. If you ever see like UART, U-A-R-T, that is a method of device A communicating with device B. And anytime you communicate, you need 2 wires, a transmit and a receive, okay? So if you just want to receive data from a sensor, like a temperature sensor or something like that, You're just receiving. You're not transmitting anything, so you only need one wire, one TX. And that will get wired into one of your digital or analog ports. Depends on the sensor. We'll talk about that later, okay? So up here, you notice that on this particular one, the Arduino Uno, the very top, we have digital I/O pins. The very bottom, we have select analog I/O pins. And also, I'm going to zoom in here for you guys. Look at this right here. We have a pin right there that says 3.3 volts. We have a pin called 5 volts. And then we have V in. Okay? V in utilizes more of your converter right here. And it's the most wasteful on energy. Now, if all I need is just the CPU to do some minor things, I'm going to use 3.3 volts. If I have something like a 3.3 volt battery, it's extremely specific. Usually, we use the 5 volt because 5 volt is super easy to go ahead and customize. It also gives you some leeway because if the CPU only needs 3.3 volts, then it will chop only what it needs, and you'll just take that 3.3 volts off the 5. And 5 volt gives you the most range. It's very versatile. And then you have this pin right here, which is called ground. You're also going to see ground probably up here someplace. It depends on the Arduino, but I have 2 pins of ground right here that notice how they're highlighted in white. That is going to be extremely important because you're going to use one ground locally to power the device, right? You need a positive and a negative. But also, we have 2 pins for ground because what we like to do is have something called a common ground. So if you have multiple devices within an entire system, you have them all sharing the same ground. That way they're triggering, like we'll talk about that in a little bit, but triggering devices and switches and relays and activating things is so much easier because it's already got a common ground. So all we have to do is allow that ground to come back. So what I just said there might confuse some of you guys because a lot of people think that things are triggered using positive. That is very, very wrong. Even things like this little button sensor right here, there is a ground on one side, and when you press a button, it shorts the ground, and that ground goes back to the CPU, and it makes something happen. Things are almost always triggered with ground, not with hot. There's a variety of reasons for that, but almost everything is triggered with ground. So from there, I have a board over here. Maybe I'll draw it out for you. But CPUs, and even devices like this, use something called a pull-up resistor. And what that does, imagine a pin coming off the CPU, and it's just sitting there, right? And it's waiting to receive a ground to trigger something. How does it know? How does it know that ground is there? There's 0 volts, right? Ground is 0. There's no voltage on the pin, so even if you clip that pin off, there's no voltage on it, right? How does the CPU know that there's nothing there? What it uses is a pull-up resistor to VCC. Okay, VCC is the 5 volts, 3 volts, etc. Okay, that's your voltage for operating whatever it is. VCC, so VCC and ground. Okay, so you got this pin. There's a little resistor that pulls that up. So if you were to measure from ground to that pin, when nothing's happening, you should see your VCC, which is like 5 volts, whatever, right? Now, when something happens, so let's say one of my float switches right here, I got a couple float switches. How does it know that that float switch is activated? Well, that pin is sitting at 5 volts with that pull-up resistor, and what happens when that switch closes, it sends ground through the switch up to that pin, and that pin, that little resistor, will now go low. So that pin now reads 0 volts. So if we talk about pull-up resistors, a lot of times they're internal on the chip. You'll never see them. Sometimes we have to wire them in manually to create that 5 volts so that the pin knows when something's happening. When, you know, a switch is closed or something like that, it's going to pull a low signal, not a high, okay? So that's something that you guys should always remember. Let's see. In my opinion, Arduino is already a bit outdated. Nowadays, ESP32 is a much better option. I completely agree. And plus, ESP32 is much more versatile. I mean, it's cheaper too. So, what is the analog output used? Okay, let's get back to that and let's talk about some of that right here. Okay, so we have analog input, we have digital. There's 2 pins right over here. Whoop. See how it says TX right there? And it says RX right here. So this is the transmit pin, and this is the receive pin. And that is going to play a part later on when we talk about I2C or I squared C. Remember I talked about when 2 devices want to talk with one another, there's 2 wires that are necessary. Well, there's actually 3 wires, but anyway, transmit and receive allows communication to go back and forth. So it's transmit, receive, and usually ground, a shared ground. So again, common ground, right? So because that tells you what's high and low on the signal. All signals have to be referenced to something, right? Like even this battery voltage right here. If I were to put my multimeter on 1 pin, my multimeter would still read 0 volts. Because it's not referenced to something. So that's why you have to put 1 meter lead at one side of a battery and 1 at the other, because now it's referenced to the other side, and it tells you the voltage between those 2. Well, it works the same way with communications. So you always have a common ground between components, and then you have a transmit and receive, and they're just, you know, they're sending, receiving data while the ground is sitting there, and it's measuring against ground. Okay, that's how communications work. So these 2 little pins right here, on my latest project, I have some displays, like LCD displays, and they use that right there. They use I2C or I squared C to communicate. And I have another project here where I didn't have that type of display. I had the old style display that just has a whole bunch of pins, like I don't know, 8 pins, something like that. And I had to wire each and every one of those stupid pins up to the microcontroller. So that would be like digital pin 1, 2, 3, 4, 5, 6, 7. All those digital pins, bam, they're gone. Because now I need all those pins for my project so that I can read the LCD. How crazy, right? So the newer displays that say I2C or I squared C LCD display, always get those. Always get those. Don't get the old style, all right? So anyway, that's what this little TX and RX is. And we do have just a couple other things in here that you're probably never going to use. The question was, what is the analog output used for? Well, you know something? That's a really good question because we have analog input, but we don't usually see analog output. I mean, you could use it as a device that measures something, and maybe you're giving an analog output for something. I don't know why you would, because what you're doing is you're taking data in from all these sensors, and that's the brain. The brain doesn't necessarily want to send an analog signal out because that sucks. Analog signals suck, right? They degrade over space. So they're subject to things like interference. It's not very efficient. Arduinos would rather convert it to a digital signal and send it out. Because if a digital signal is degraded, it will know because it won't be readable by the other device. And the other device can say, hey, send me that packet again. I couldn't read it. And then it will send it again. You can't do that with analog signals. Analog is like the old days of analog TV. You know, you go to tune in and it's all grainy and you couldn't see anything. That's interference. Digital TV is nice and clear, and it only gets degraded when it loses too much of the signal, and that's when you start seeing it get blocky. But it takes a lot to do that, okay? So anyway, Jake W is tuning in from Florida. Excellent. All right, guys. I know I'm going kind of slow, but that's because this is really designed for helping you guys get started, because you could start using Arduino today. You really could. And the amount of projects and stuff that I've used it on is just insane. There's literally almost nothing I couldn't use it on. Almost nothing. And I could, I have my digital garden here. I started that 2.5 days ago, and last night it was done. All right, programming and everything, like over 1,000 lines of code, done in just 2 days. That's the wiring, everything, the fabrication, all the components, getting the drivers installed and stuff, which we'll go over in just a little bit. Man, it was all done in 2 days. Try doing that. Without AI, it wouldn't have been possible, okay? So it's so cool, so easy to use. And I'm just here to inspire you guys to maybe start doing some stuff. All right, so now you guys know what the components are on an Arduino. What is the differences between Arduinos, okay? Because there are a bunch of different ones. And again, I'm calling them Arduinos, but they're all just microcontrollers, really. All right, sorry, my voice is gonna disappear if I keep talking. Okay, so let's see, reset button, that's all the different components. This here is the programming environment. Again, it is free. And if you see the little double dashes right here, those are just notations that allow you to see what's going on in the code. Like it says right here, pin 13 has an LED connected, yada, yada. AI is fantastic at labeling not only like what's going on, but if you want to choose between this range and this range, change this value right here. It tells you step by step in the little notation. So if you ever see the double dashes like that, the little hash marks, those right there are notations, and that is not the program. This right here is the program that integer LED equals 13 void setup. You don't need to know that, all right? You don't need to know none of that. We're going to step on. It's showing you what's going on inside the Uno. You don't need to know that, okay? The different types of Arduinos. This is where things are going to be a little bit different. So based on your requirements, your power requirements, the amount of inputs and outputs that you need, all that stuff is going to change what type of Arduino that you need. And mind you, one of the most expensive Arduinos that we have here is like the Megas. I've got one right here in this kit. It came with an entire kit for $65. The entire kit with sensors, wires, and everything. $65. It's crazy. It's so cheap and efficient to get into Arduino. So the only thing that you should probably be aware of is you see right here, it shows the Nano. And you see how it's got the micro USB port right here? There are ESP32s that somebody already talked about. ESP32s, usually, not only are they a little bit faster, but they come with USB-C. Why are we still using in 2025 USB micro ports? I don't know, they suck. USB-C is the way to go. It's faster, it supports a higher charge rate and run rate for current, and it's universal for direction. There's nothing worse than possibly damaging a USB port. So just be aware of that. So we have a whole bunch of them here. The Mega 2560 right here is one of the big daddies. We've got the Arduino Mega 80K and a few of the others. But mind you, like, Arduinos are also changing, and they're coming out with, it's open source, so people are coming up with their own designs, and they're getting better. All you have to do is know exactly what you're working with, like this Arduino Mega 2560, which I have right here in my garden kit. That is highly suggested that you put that at the very top when you do your definition of what you want to accomplish to the AI model. Like, I'll show you how we do that, and I'll take you right through some of the heartaches and stuff. Don't worry, guys. We'll get into programming these things. That's half the battle, right? The hardware is half, the programming is half. We've been able to take the programming and slash it considerably. So now it's just a piece of the pie. And in fact, you're usually going to fight the AI models, especially ChatGPT. We'll talk about that later, guys. So anyway, there's a whole bunch of different types of Arduinos. They all do certain things really well. Like the Nanos, if it was me and I'm just getting started, I would buy one of those kits and maybe buy a Nano to goof around with. I did blow up my first Nano. I'll admit, I did blow it up. Aforementioned like variable power supply did get me, okay? But that's okay. They're only like $18 to $20. Who cares? Throw it in the trash and press on. So some of them can be, you know, 30, 40 bucks, but that's still really cheap, okay? That's still pretty cheap compared to what it can do. So let's go ahead. This is something that's going to be pretty important for you to do when you get your Arduino, is you type in whatever it is pinout. So Arduino pinouts, these are just all the different Arduinos. However, if you have an Arduino Nano, then you type in Arduino Nano pinout. You need to get familiar with your particular Arduino, all right? And of course, they're going to default to the Uno, which I've never used before. Okay, here we go. So this is the pinout. And right here, guys, these right here, AD, those are analog to digital converters. That is your analog pins. You can see right here, analog in. IO reference, that you might not even ever use that. Reset pin, if you have like an external power switch and you want to create like a reset to reset it externally, instead of opening up your project, you would wire that to what? To ground. That's right. Remember, things are switched using ground. We have 3.3 volts right here. We have a 5 volt. We have the ground. Remember, redundant grounds. Why? One ground is the power of the CPU. The other ground is to share with other devices, because having a common ground allows you to do things like switch very easily. And I'll show you how to do that really easily. We're gonna talk about that. The power in, this is a DC barrel jack. It has variable power. It is not the most efficient. The 5 volt in is probably the most efficient way to use it. Right here's a voltage regulator. We got the fuse. Right here's the USB, the D style USB. We have a reset button. All Arduinos have reset buttons on them because sometimes you goof up and they have to reset. Ask me how I know, okay? And let's see. We have our pins over here. We have analog reference right here. We have a ground. And mind you, you don't have to know what that stuff is. ChatGPT or Grok or any of those AIs, it will tell you to connect to this pin and then wire it to this component. It tells you step by step how to do all this. So you don't have to know like all the details. I just want you guys to look at this and understand what you're looking at. So the TX and RX, that's the I2C or serial communications or whatever. Those are digital pins for sending and receiving data. Then over here, these are all your digital pins. And there's also a really interesting point right there, okay? See how it says PWM? Pulse width modulation, okay? So if you want to control motor speed or something like that, if you want to dim a light like an LED, there's PWM, and that's the digital pins right here. And as you go to a different Arduino, you might have PWM on different pins. Just be aware that that's what it stands for, okay? Let's see. When powering an Arduino Uno R3 via the 5 volt pin, what's the maximum total current I can safely draw before risking damage to the USB source? Okay, so here is also an interesting thing. I have pulled a lot of current in series and parallel to an Arduino. They operate really good when they're undervolted to a certain point. There's a lot of CPUs out there that as soon as they start dipping in voltage, they start acting funny. These ones actually continue operating for a little bit before they crash. Just be aware. We're going to talk about setting up power supplies and stuff. I'm going to open up my projects and I'm going to show you exactly what's going on inside them, okay? They're not the best projects in the world. They're not the neatest, but they work. And also, I can troubleshoot and or give you guys demonstrations of how they function, because I didn't go the full Monty. I didn't like create circuit boards or anything. Most of my projects are still using breadboards. Breadboards we'll talk about in just a moment. Okay, so there you have it. That is the anatomy of an Arduino. Mind you, this is the Uno, but there's a whole bunch of different ones, guys. And don't worry about understanding what all these pins mean. You should just know that these are digital pins. These are analog pins. These right here are your voltage in. And this right here is the USB to program it. Ta-da, there it is. It's that simple, it really is. Okay, let's go through that. Let's talk about where you can get Arduinos and start. So this is one of the kits that I have. And mind you, I said kits, plural, because I burned through some components and stuff. It's so fun, and I've just gone through so much different stuff. This here is $65 for this kit, and it is so cool. Let's go ahead and take a look. So right here is the heart of my project right here, which is the Smart Garden. It's a electronic garden greenhouse, and it has all these sensors and stuff, and it can run motors, and it can turn on fans and pumps and stuff like that. All that can be done inside this device using this guy right here. And this is the Mega. So this is the Mega R3. This isn't the exact kit that I have. I've got the Mega 2860 or something like that. And let's just talk about what you get in the kit. So right here is the actual Arduino. You can see some common denominators here. We have the analog pins down there in the corner. Up here we've got TX and RX. We've got a bunch of TX and RX. How cool is that? And notice there's two pins over here called SDA and SCL. All right? SDA and SCL, that is logic and clock signals for the I2C or I2C. But man, look at all the communications on this board. You got RX and TX there, you got RX and TX over here, like 3 sets there, plus the SDA and SCL to like power your display. Very cool. We have an RFID chip right here. So if you want to experiment with some RFID, you can use that. We got some potentiometers. I've got some buzzers right here. We've got some surface mount buttons, whole bunch of resistors, which you will use. This guy right here is a buck converter. So you put a DC voltage in. Right here's the power supply. It's probably like a 12-volt power supply. And it will chop only the voltage you need, the 5 volts, 3 volts. In fact, you can see it labeled right there, 5 volt and 3.3 volt. And it's going to output that on these pins. You see these 2 pins right here, 2 pins right here, 2 pins right here, and 2 pins right here. Those are pins that are facing downwards. I'll show you that in just a moment. And that is going to sit right here in your breadboard, okay? See how it's got a voltage rail right here, the plus and minus? Down here, a plus and minus. Albeit, they're going to be backwards because breadboards haven't changed in like 40 years. So you got the plus and minus here, and then all these right here are where you can hook up jumper wires. As you can see, we got all the rainbow jumper wires there. You're going to use them. I've got a regular brush DC motor right here. We have a stepper motor, which also looks like it's got a gear reduction. So see how it's offset and up here in the corner? That means there's gears in here. So it's going to have a high output for torque. and also for position, but it's going to have very low speeds. So it's a gear reduction. Right here, I've got a servo. So if you want to, let's say, have a robot that moves, or people use servos like that on like RC airplanes to control the flaps, the ailerons, or whatever you want to call them, ailerons. Anyway, that's a servo. And a servo is something that you can give it a position, and it will move to that position, and then it stops. So it's kind of like a stepper motor, only extremely limited movement. So you can have it like lift something up, stack something, come back down. Lift something up, stack something. That would be a servo. Okay, so that's this little guy right here. We have a PIR sensor. So this little round guy right here, I've got a whole bunch of them because they're so cool to use. In fact, I got a project right here I'm going to show you guys where we use a PIR sensor, and that is infrared motion detection. So I can sense when somebody enters a room, and when somebody enters a room, I have it start something. And in case for this project, I have it start a fan motor, and I also have it light 3 little LEDs. And it does that whenever it senses motion, when it's nighttime. We can also detect night or day with sensors, and I'm not seeing it here in this kit. Oh yeah, right here. So these are LDRs, I think, light detecting resistors, these two right here. Boop, boop. So these two little guys, they can create an analog signal because it's a resistor. So as the light increases, the amount of voltage that's going to go through it is going to change. So increasing, decreasing the light allows the machine to detect if it's light or day. And I'll show you guys live examples of that right here. And they're set up and they're all running. And anyway, those are LDRs. These are PIR sensors. Right here, we've got a potentiometer. We've got some NPN transistors right here, it looks like. We've got a whole bunch of LEDs, electrolytic capacitors. We have, let's see, one of these, I think this is a stepper motor controller, this guy. This guy right here looks like it's a time chip. So it keeps recording data or something even when it's powered off. You can see it's got a 2032 battery, I think. This guy right here with the two like speakers, that is an ultrasonic sensor. And the ultrasonic sensor can detect, because it sends out high frequency sound or waves. They bounce off something and it measures how long it takes to receive them. So one of them is a transmit, one of them is a receiver, and it sends out the signal, it bounces off something, and it receives it, and it knows if you're getting closer or further away. And it is also an analog signal because it will, actually that one might be digital. We'll talk about that in a little bit. But anyway, it just measures the signal, and it knows if you're getting closer or further away. They use those in things like robots. Proximity sensors, they use them for occupancy sensors. Like if you go into a room, it knows that you're there because, you know, maybe the door got opened up and it's reflecting off the door or something. There's 100 different uses for it. We have a gyro. Let's see. Oh, right here's the motor driver, this little guy right here. So we've got a temperature and humidity sensor. That's this little blue guy right here. I've got one of them wired in currently on this project. It's got a whole bunch of sensors. We got a moisture sensor right here. See how it's got the copper lines that go down the stalk? Well, it can detect fluids, and as the water level raises on that strip, your resistance is going to change, right? Because pieces of copper are resistors, and as that copper gets shorter and shorter, the resistance goes down, right? So that's how it knows the water level on that little sensor right there. I don't know what this other guy is right here. It looks like a microphone. I don't really know. I don't think I have that one in my kit. We've got a remote control. I've got a relay right here and a thumbstick, like on a gamepad. And let's see, this guy right here is inertia sensor, to detect when something's moving left, right, up and down, etc. So that's this little guy. And then we have a keypad right here, which was sometimes a little bit challenging to set up. And then this guy down here is a LED matrix so that you can write messages in really low resolution. Um, that's real. That's a lot of work in order to make that thing happen, but it's kind of cool still. But this pad right here was a little bit of a project to get it to work, but I got it up and running. We have a 9-volt adapter right here. That's kind of cool. So that 9-volt adapter allows you to power your Uno project off a 9-volt battery. I have no idea how long it's going to last because you're converting 9 volts down to 5 volts, so you're losing some electricity to loss. Anyway, and this guy right here is a developer board, and that will this guy right here will attach to this one. So this guy sits on top of this, and you can solder things and connect pins and stuff to this one and hard affix them. And let's say whatever you're working on doesn't work out. Well, that way there, you're not destroying your main board, you're just destroying this board up here. That's kind of a cool addition. I really like that. Plus, notice all the test points right here. Very easy to get to versus this one. Look at this. Like how do you get to all those test points? You can't. Once a pin's in there, that pin is blocked. And if you have this guy fastened down, you can't access the backside of the board. And trust me, you don't want to because pins will pop out. So this little developer board right here is super cool because you have access to all these digital pins right here, and you have access to all these cap pins right here. Plus you can wire pins in. These things are so cool. I didn't use mine for my big project here. Maybe I should have. But anyway, we'll talk about that. So anyway, that is the kit. You get all of this for $65. And that is a super cool way to get started. And there are a whole bunch of kits. All you got to do is go in and type in Arduino kits. And there are hundreds of them, okay? Hundreds. Look at all these. Elite Explorer. This is the ESP32. So many. There is one other thing I wanted to show you guys from that kit that's going to change your life for the better or for the worst. Let's go back into it because I had to learn this the hard way. See all these pins right here on this LCD display? This is a older style LED display. And if you see all these pins, run. It's okay to have in your kit. You can wire it up, and they tell you exactly how to wire it up with the AI. However, the I2C displays have like 4 pins. 4. And they're so much easier to use. And they, because those 4 pins, it's a digital signal, you can have more data on it than with this old style one. All right, so the garden center right here that I've got some big displays on there, and they have way more data on them than the display for that I have on my other project right here. And I'll show you guys those projects. So anyway, guys, that was what you get for the kit. I recommend getting a kit and just dicking around with it. Have some fun and just experiment, because that's how you're really going to figure some of this stuff. Hi everyone, I'm reading some of the comments over here, so if I look like I'm a little distracted, that's exactly what I'm doing, right? And again, if you guys have any questions, go ahead and type them in, and we as a community will answer them. I'll answer them live right here, right now, if I can. So let's see, we have some really cool sensors. This is on the Arduino.cc website. So this is the official Arduino stuff, right? We have like oxygen sensors. Look at this, electrical conductivity sensors. How cool is this? I mean, a machine vision sensor, capacitive soil measuring sensor. The resistive sensors suck because they degrade. The capacitive sensors, like this one right here, that's what you want if you want to detect how moist soil is. Earlier, we talked about UART, okay? UART allows the high-speed transmission of data. Right here is a UART ultrasonic sensor. The good thing about buying stuff off of the Arduino site versus the stuff off Amazon is probably going to be the fact that the stuff that comes off Amazon, I'll admit, sometimes, I mean, the quality has been pretty good, but the documentation on what that thing is sucks. However, if you take a photo of the component that you currently have and you import that into the AI, it will tell you exactly how to wire it up every single time. It's the craziest thing. So remember that, guys. If there's ever something you don't understand, you can take a photo of it and upload it to AI, and it will work through the problem with you step by step. Very cool. So UART, when you see UART, that is what it means. It's a method of transmitting, okay, data. Temperature and humidity sensor, that's a cool little guy. PIR sensors that we talked about earlier. There's a kind of a crappier version of it, I guess, because this one looks like it's a little more complex. Although $9, that's a good price. We got light sensors. We already talked about light sensors with the LDR sensors, light detecting resistors. Oh, right here's the moisture sensor. And remember, I just got through talking about resistive versus capacitive. This one right here is almost definitely resistive. And these two tracks right here that detect the moisture, they will start corroding like immediately. So use capacitive sensors, do not use resistive. We have a Hall effect sensor. Very cool. I love that. All right, and well, you get it. Okay, there are hundreds, if not thousands of sensors that you guys can get. All sorts of them. All right, let's go ahead and let's talk about some projects, all right? And to do that, boop, let's pop you over to the second camera, guys. Okay, guys, so I have a wide variety of projects that I've been doing. Most of my projects see, here's my my kit. This is the one that it came with. But I have it opened up, and all my wires, I keep all my wires in here because I have a tackle box, and this guy here is all my sensors and stuff. So that's what I suggest you guys do, because you're going to access the wires like very frequently, and the sensors not so frequently. Okay? Let's see. I have a bunch of stuff here that we're going to talk about. Okay, so let me move my phone over as well so I can keep track of people's questions. Pete West says, I used to have resistive moisture sensors for a couple of Arduino projects, and they are unreliable. Absolutely correct. I have since changed them and super reliable. Yes, very good. Okay, here. I'll put my phone in frame. All right, guys. So, for my projects, I've taken a couple different approaches. One way is using the breadboards, which I'll show you in a moment. And the other way is to manually solder up your own circuit boards. It depends on what you're working on, because it's much more difficult to undo something with this. However, if you know how you're going to do it, or let's say you want to create a prototype, these circuit boards are very inexpensive. In fact, let's see, I've got hundreds of them here. They come in a little kit like this, also on Amazon. And look at this, various sizes. Even if you guys want to practice your soldering skills, which I recommend you do, get one of these and get some generic components. They're so cheap, guys, like less than 20 bucks. You can get a handful of components. And then take some time and get good at soldering. If you suck at soldering, like wire to wire or wire to circuit board, then you need to stop, all right? The core skills still have to be refined. There's no way around it, guys. You have to be pretty good at soldering, and you have to be reasonably good at things like generic electronics. Even though the AI tells you what to do, there's still some shortfalls that you can run into if you're just goofing around, not doing something correctly. So your generic electronics are going to help you figure out how to do your project. So like this right here is a button, right? Just a button. That would be wrong. This is not just a button. There is no such thing as just a button, guys. No such thing. This is a latching power switch, okay? Or a latching button. Means you push it on and it stays on. It's currently shorted between this wire and this wire. I press it again and it's now an open between this wire and this wire. This is different than this. This is a momentary button. Momentary button, as soon as I release it, it's no longer shorted and it's no longer sending the signal. Momentary buttons, latching buttons, there is a difference, okay? Relays, I don't have any over here, they're all over behind me. Actually, I got a couple of them right here. Relays, you gotta understand about dual pull, dual throw, and dual pull, single throw, and single pulls, single pull. You know, you have to understand basic electronics because it's going to matter a lot when you're switching two poles. Like, well, my project over here, I'm switching both my positive and negative at the same time. Dual pull, single throw. Dual pull, dual throw. You have two poles on each side, you know, and it's switching two of them. So this right here is a standard relay, and I have normally open, common, and normally closed. You need to understand normally open means that it's until you trigger it, there's no signal. And normally closed, there's signal, and then whenever something happens, it opens up. There is a difference for why you would use that. Here, I'll tell you what, let's bring you guys in. Come on. Zoom. There we go. All right. So on a regular relay, we have DC plus, DC minus, and there's one pin right here marked in. Yeah. So DC plus and DC minus, that's how you're powering the stupid thing. In is your trigger that tells it latch, unlatch, whatever. That's your trigger. That comes from the Arduino. So your trigger is going to be either high or low. You see this little signal over here? High, low. So that means it's going to be either a 5-volt signal or ground, right? Low. I have mine set up to trigger high, and that's because I don't want them to clickety-clack like when you boot up the machine. Don't worry, the AI will walk you through that. But you see like this H and L, that's what it means, high or low. So relays, you guys should also be very familiar. They're rated with your voltage. You see right here, this is a 5-volt relay. You get them on Amazon. Of course, guys, you can get all this stuff on Amazon. You get like packs of them, like this. Or you can get them all joined on the single board. So let's say you're trying to control a whole bunch of things. There might be a giant board with like 8 relays on it and individual trigger pins. So you have 2 power pins for 8 relays, and then let's say 8 different trigger pins. Very cool. Much less wiring than these guys, but these guys here are very versatile. I have a whole bunch of them. So relays, guys, got to understand generic electronics with relays. AI, if you ever are confused, it will walk you through that. Don't worry about it. Again, None of this stuff is complex. Even if you had a question with what type of switch this is, you didn't understand it, or you didn't know what this sensor was, you could take a photo of it and you can import it into AI and it will tell you what it is and how you use it. It's so crazy right now, the amount of stuff that we can do. It's so cool. Okay, so that is a latching through panel. See how it can mount through the panel? It's not surface mount. This guy right over here is a flush mount. This is a through panel. See how it's threaded? Or they also call them bulkhead. Again, this is stuff you learn as you go. This is a bulkhead power switch or through panel power switch. These are flush mounts there, and you can see I got a power switch right here. So let's go ahead and let's walk you through some projects and show you what I have used the stuff on, okay? You can move this over. I've done videos on some of these. This one here is a game. I had an epiphany one day when I was talking with a fellow biomed, and I came up with this system right here. And I did videos on it, and people said, oh, that's the stupidest thing ever. However, when people actually play it, like for Christmas and New Year's, I had a lot of people over at my house. And this guy right here entertained everybody for hours. Because what it does is players get cards, and you don't know what's on it, right? Because it's a QR code. And it's a game of Risk, because as you put it in here and you hit the button, it scans the QR code, and it's going to inflate or deflate the balloon. So it zeroes the pressure sensor, and you can see right there. Oh, here, let me adjust the. There we go. So this is powered by a Arduino Nano, and there's some solenoids in there, some pneumatic solenoids to release air. There's an air pump in there, and not too much else. So this right here is a barcode scanner. And when you push the button, you can kind of see it there, it will try to scan a barcode. And because it didn't register anything, it says, okay, we're just going to give them a couple seconds worth of air. So let's try this next one. Okay. And now I added that delay. And this one here says 6 seconds. And mind you, I can control the contrast with this button right here. 6 seconds. So when this balloon gets really big, because it's a balloon, you don't know when it's going to pop. It really is kind of arbitrary. It makes it very, very intense, like when this guy gets inflated up there. So this was just a game I came up with out of nowhere. And I had an entire room full of people playing, and it was very intense. And when it pops, it's super loud, and it's very stressful. And it was so much fun. So anyway, this is powered by a tiny Arduino Uno, or Nano. It's just a little tiny guy. In fact, let me show you what he looks like. I don't need to show you guys wires. You guys get that. See, I got a little motor there. Okay. And you can see my kit will expand quite a bit. The kits, they come with 8-segment LED components. We got some meters. We've got pressure sensors. Let's see what an Arduino pressure sensor looks like. Zoom. There we go. This is what comes in an Arduino pressure sensor. So you have either bent or straight pins. And then right here's the pressure sensor. How crazy is that? So now it's up to me to put the pins in at a 90-degree angle, or straight up or straight down. I think I would prefer to put them at an angle like that, just like that. You flip it over and you solder those pins, and there you have it. Notice how everything is silk screened, ground, I've got SCK, out, and VCC. So I talked earlier about how you have a data pin and you will also have a clock pin. So SCK is a clock, out is the data out, VCC is the 5 volts, and ground is ground. And mind you, guys, again, common ground. I'm going to show you guys how we have common ground, okay? So that is a whole entire case of, here, I'm going to just leave this guy right here. Maybe we'll utilize him. Let's see, what else we have? What else? Well, I have a whole bunch of these PIR sensors, and notice how we have adjustable sensitivity. Very cool. And you can also have this as continuous activating, or it activates once and it latches. You have that option. So again, all these things are very, very flexible according to what you want. I've got one of those buck converters right here. See, we got a DC barrel jack, we got a power switch, and I've got a USB. That is not to program it, that is USB to power it. All right, and let's see, I got some buttons, you guys get it. I have another buck converter here. And my projects use a lot of these. So this is a 3 amp maximum buck converter. So we've got out plus, out minus, and we got our input. So this is a DC to DC converter. So let's say I have 12 volts coming in, which is how my projects are run. And output, I might have 3 volts coming out. I might have 5 volts coming out. I might have 1 volt coming out. Depends on what I'm trying to achieve. And these things are so inexpensive. I got a whole, well, I mean, look, I got a whole bunch of them there for like, what, $9. I got a whole handful of them. I mean, look at all these. So I got a bunch of these, but that's the cool thing is even if I blow one up, who cares? Get another one. And again, through hole soldering, get used to it, guys. So this is an LM2596, and right here is a little potentiometer. And this guy here is how you adjust how much voltage comes out of this thing. And it takes a lot of turns, believe it or not. Like lots and lots of turns, like 20 revolutions to get this guy down to like 3 volts. So that's a little buck converter. I'm gonna put him up here. Let's see, I'm gonna get my PIR sensor. We're gonna make a sample little circuit here, and I'm gonna show you how we build out circuits. And let's go with a breadboard. I've got big breadboards and I've got little ones. These are very inexpensive as well. You can get them for like $5 or $6, sometimes $10. Inexpensive, guys. So let's see, we got our breadboard. We've got a power rail right here. And let's see, I've got my sensor. Let's hook up a display. Yeah, we're gonna hook up a display. This, remember guys, I said the I squared C or I2C, they have 4 pins instead of a whole bunch. Look at, here's all the pins I would normally have to connect versus just 4. So this little chip right here takes a digital signal and it outputs it on these pins to how it needs to be. Much, much easier to use this kind than this kind. This one here is a little bit of a pain in the butt. And you've seen that I was adjusting the, I can adjust the display right here with that one. This one here, I don't need to do that. Most of that is just handled. And if I do need to adjust it, you can see right there, I've got a pot that I can tweak if I need to. I've never had to touch the ones that I'm doing. Let's try a Arduino Nano. All right. Arduino Nano. Let's see, I got one right here. So this is how they come, and they're pretty inexpensive, guys. Like $20. You get this little microcontroller. And you guys are probably already saying, oh, wait a minute, that is not an Arduino Nano. Right, it is an Arduino Nano clone called the ESP32. It has the USB-C port that I was talking about, and it has Wi-Fi capabilities. And I think this one here is a little bit faster. Let's see. Let's go ahead. Let's zoom in. So you guys can see what I'm doing. Okay. So there it is. Arduino Nano ESP32. Little reset button. And all our pins right here are down the side. And they're all labeled, albeit they're very tiny. So we're going to go ahead and we're going to start building this out. First off, let's talk about your breadboard. So see how it's got this dividing line down the middle? And here, let me get some wires so I can show you guys proper. Let's try these two. Okay. All right, guys. So here we've got all these pins on this side and all these pins on this side. All these ones here on each side are wired together. So let's start at 20. So this pin, this pin, this pin, this pin, and this pin, they're all shorted together. That means that we can connect multiple wires and stuff to each pin. And all we do is we insert the wire like that, and it is good to go. Okay? On the sides, we have negative and plus. These are voltage rails here and here. So this right here is going to be all your positives. This right here is going to be all your negatives. Okay? So let's go ahead and see what that looks like. I generally try to put the Arduino in the middle of the breadboard. You can see it right there. That gives me 2 pins on each side, and if I have some pins that I need more of, like on my digital pins, then I can move it over. See? You move it over quite a bit. Just got to make sure that on that segmented line down the middle, half of them are on that side, half of them are on this side. You cannot do it this way, okay? They're all shorted together. So I try to do it like that, right there in the middle. Right? Just press it down. And some of my pins are going in kind of difficult. There it is. Okay. So this guy is now wired in. Ta-da! How easy, right? So now we need to power the stupid thing. There's multiple ways that we can do this. Here is my little voltage regulator, little buck converter. The pins that I talked about that are on the underside, look at that. It's almost like they thought this all out. See how they match up with the voltage rails? I'm just going to plop it in there just like that. So these ports face away. And over here, we can select 5 volts or 3.3 volts. So we're going to select what our voltage rails are going to be. I choose 5 volt and I leave them at 5 volt. It's good to go. Now, I don't know if this buck converter right here is broken or not. I think I had one that's broken. And if so, then one side's not going to have its power rail. And that's okay, because we can wire them parallel. Like I can put from this to this. See how it says plus? Pay attention to your buck converter. See how it says that's a plus and this one here's a plus? That means follow it. Don't necessarily follow the breadboard. Always follow your pins up here in case they're reversed. I had one of these buck converters where they were reversed. So irritating, guys. So anyway, right now they would be in parallel because I have that jumper. You get it. Okay. These right here are mainly for diagnostics. So you can either test right here at the pins or you can test right here at this breakout. You got your power switch. You get it. Okay. So this right here is going to be my display. We're going to wire that in just a moment. This right here is a cool little guy. This is a sound chip. So it's got storage, and it allows me to store like WAV files. And I don't know if you guys have ever heard of the screaming goat. It's a device that you plug into like a USB, or some of them you can just put behind a desk and they have like an internal battery. But what it'll do is it will randomly send out like a screaming goat, like rah, you know, and then like you're trying to find it, but it goes silent. And then like 15 minutes later, it screams again. You can do something like that with this. I was going to do a Christmas tree shaker, which is a device that you put inside the tree, and it shakes the tree randomly. And then when it senses motion with the PIR, which is this guy right here, when it senses motion, it's going to play the shh, quiet guys, they're coming, you know, and then, you know, then it'll shake the tree at like maybe randomly within an hour, 2 or 3 times. And I've got a little motor right here that I'm going to use as my shaker. So it's got the offset weight. Again, Amazon, be surprised at some of the cool stuff you can get. I never got around to doing it before Christmas hit, so here we are. But this is a little sound chip. I'm just going to go ahead and put it right there. This is my pressure sensor. Again, these aren't soldered in, so bad on me. This right here is my PIR, and if you look, there's no writing on it, right? You can pull the shield off. Right there's my sensor. Mind you, it is kind of delicate. And there's writing on the backside. VCC, out, and ground. This one over here is ground. We got it. Okay. So the VCC is closest over here to my diode. That is probably reverse polarity protection diode. If I'm correct, I'm pretty sure I am. So that protects this board in case some goofball like me hooks it up backwards. It's got that little diode right there to protect it. Okay, so I'm going to wire that PIR sensor and this display. And let's see, what else should I wire into it? I could do a temperature sensor or something like that. Let's do a relay, okay? So I've got my relay there. Let's get rid of this guy. He's just going to give me problems because it's not fastened down. We got these jumper wires, and the jumper wires we're going to connect. Remember, I said that there's voltage in and ground and stuff. So we got the ground pin, and we are going to connect it to the negative on our rail. That is any of these right here. Boop. Here, I need more wires. It's so easy to buy extra wires and stuff from Amazon, guys. You can see on my kit, there's female to male, which is this one. And I buy them for like $9. You get this many wires right here for like $9, something like that. Maybe it's $6. And you just rip off the wires that you need, and then you're good to go. So we are going to actually do that right now. So this guy right here, notice how it's got screw down terminals. So that would be our male to male right here. And we have 3 wires going into it. So let's rip off 3 wires right there, just like that. Okay, male to male. It's got VCC, ground, and trigger, which they say is in. So we're going to separate this guy out, just like so. We're going to do trigger gray, and we'll do white and black. And let's see, I'm going to hook this guy up to, let's do D2. Okay, D2. And we will do white to positive, black to negative, and is connected to D2. Okay, see that? So now what we got to do is we now have to wire this guy on the same side right here. DC plus, DC minus, and in. Let's go ahead and loosen those terminals up. All right. So trigger, the most important one. I'm going to connect that guy to in. DC minus and DC plus. Again, reference minus is going to be the black. Right. Okay. Precision screwdrivers are your friend when doing this stuff, guys. There's some really small connectors. Okay, and it's set for high trigger. And now I would just connect whatever I want it to do. Flash a light, whatever, turn on a motor. We would connect that on the output side. So let's just say that that relay is done, okay? Let's take our PIR sensor. And again, on the inside, it says ground is the far side, VCC is my side. So these ones are pinned, so that changes it. Now we need a male to female, because the female is going to connect to the PIR, and the male is going to be pinned out. One more time, I always double and triple check. So VCC is over here. And let's see, I think I did black to negative. Hold on, guys. I'll get it. There we go. You'll see that they just kind of push on, like so. Ta-da. There it is. And my PIR sensor, let's say I use D4 for that. Let's go D4 here. And these ones here. You can plug it in anywhere down that rail. Okay, so now my PIR sensor is in. Now let's remember to do one more thing, guys. Since I'm doing it this way without working with AI, AI normally tells me where to connect things, but because I'm doing it in reverse, you have to remember to write down. So D2 is relay, and let's see, D4 is PIR. Okay, so remember to write down what you got, because you're going to put that into the AI when you tell it what you want it to do. Okay, let's go ahead and put him off to the side. Now, we've got ground on this chip, but we have no voltage. So we need to get a voltage. I also have this cool little guy right here. And this is where it helps to have a lot of different wires, guys, because we try to stick with some sort of wiring code so that you know what you're looking at. And for this one, I have a 3.3 volt here, and I got V in right here. And I've got one more ground over here on this side. You see it whited right there. V bus. We're just going to do V in right here. And this one is going to go to the positive rail right there. All right. And if I want this rail over here to be powered by that side or vice versa, you just pull off the jumper. And that kills the rail from here. And then you wire from this side to that side. Pretty easy. All right. So let's say my project is now complete. So I've got my ESP32. Oh no, we got the display, guys. Almost messed up. I wanna hook this bad boy up too. So that is going to be female to male. Again, we get our wires, and it is 4 wires. We rip them off. There we go, female to male. And now I can put some of this off to the side. And right here, we have ground, VCC, SDA, and SCL. And I will have to, we'll go ahead and connect it, but I'm going to let the AI tell me where I connect it, okay? All right, so we have it with our wires. I'm going to separate out. These are my data lines, and these ones right here are my positive, negative. Okay, and that is my display. It's almost ready to go. Okay, so the important things are we have an ESP32. I don't know if this guy's working completely. We'll figure that out together. And the rest of this is just extra. So now let's go over to the desk. And this is a 4x20, I think. Let's see. 2004 alpha. I'm getting that number from right here. And this is I2C display. All right. So with just that information right there, we are ready to go over and start programming. Okay, so that's how you use a breadboard, power, ground, and the only other thing that I didn't really share with you, maybe this one's the broke one. One of them's broke, who knows? I talked to you guys about the common ground, okay? That is where you have your ground from here, you run it over to another device or another component. Like let's say I've got a 12-volt power rail. So I've got a 12-volt power rail and I've got a 5-volt power rail. They can have the same ground. You don't connect the same positive, you connect the same negative. And now they can kind of talk to each other. So just be mindful of that, okay, guys? All right, so let's go ahead and let's see what the AI says about this guy right here and how we're going to connect it. So I've got a, so this is a 5-volt relay. Our PIR sensor should be ready. So just with that, we're ready to make a program. Okay, let's do this. I know I'm covering a lot of stuff, guys. Don't be afraid to ask questions. Let's cover it right now if you guys have some problems. When powering an Arduino Uno via R3 via the 5-volt pin, what's the maximum total current? Yeah, it's not much. Let's see. All right, anyway, here we go. Let's go in and let's start a new project with ChatGPT. So my ChatGPT I use for a lot of different things, okay? Right here's my Arduino greenhouse. And what's really cool with ChatGPT now is you can create a project. You see right here, it says new project. You can create a new project. And I thought that all the files inside the project could talk to each other. They cannot. And that created a lot of problems. It's the stupidest thing ever. Why even have a project if, let's say I'm designing part of my project with one chat, and let's say I'm designing another part of my project with another chat. So let's say I do like graphics on one, I do the coding on another, and I do, let's say, design and layout on another one, you know, using like measurements and you know, stuff. They can't talk to each other. And it's very frustrating. So ChatGPT, it does some things really well. One of them is teaching you, but other things it sucks at. So I'm just gonna let you know right now, all my projects were mainly built in ChatGPT, but it does give you some problems. So let's go all the way back to the beginning, right? All the way back. And I started out my chat by saying, I'm making an automated greenhouse using an Arduino Mega 2560. Okay? And then it starts like, you know, going off and like, oh, here's all the stuff that we could do. Because I didn't give it enough information, it's trying to get me ideas to get the whole circulation going, right? However, I already had it planned out. And this is why I'm telling you guys, write everything down, type it into a Word document, make sure it's exactly what you want, and then feed the AI what you're looking for. Because in other words, it's going to start making assumptions, and you could go down the wrong road. It did a pretty good job. It says core subsystems you need, light level, the LDRs, the soil moisture, which I don't have because mine's a hydroponic system, which why would I have a soil moisture for hydroponics? Not for the Mary J, folks, not for the Mary J. I'm growing tomatoes and some other stuff, you nuts. Anyway, water temperature, I didn't do the water temperature. I did air temperature and humidity. I did a couple other things. Actuator, so it goes into some detail, right? It gives me all this garbage before I even gave it my next thing of what I'm looking for. And I just told it what I have. So I said, here's some components I'm using, the DHT11. And mind you, I'm literally reading off my shopping list from Amazon. So the DHT11, that's my humidity sensor, development expansion board, my 4x4 matrix keyboard, passive buzzer, the DC worm gear motor. I basically told it right there, you can actually give it web addresses, like post them in there. I think I want to use this product. And it will say, hey, that's a good idea, or maybe that's not the right one for you. So you have a lot of flexibility with AI, guys. You can just feed it information and it will help you make decisions. Okay. So I do have some float switches here, which is doing pretty good. And then it goes into power architecture. And notice how they're saying do this first. Very important because everything's based on your power rails, right? Like it's like your skeleton system for your body. If it wasn't for good bones, your muscles couldn't do anything. Your heart would be useless without the bones. So that's why it says start with the power rails and then start working from there. And it's telling me about the buck converters and stuff. I'll open up my project and I'll show you guys what's going on in here. And then right here, window motor control with the dual pole, dual throw relay module. And it's telling me step by step. This is how easy this stuff is, guys. Step by step. And if you have any questions, you can ask a question. It will refine what it's saying. Motor inductive kick. See, this is stuff that only an experienced person working with motors would know about. Is that there's a power spike when you turn it on and shut it off. AC watering pump control. I have a genius way that I solved that. The 4x4 matrix keypad, that was a little bit of a trick. But anyway, you get it, right? So we just defined the project, all right? And we worked through it, and it gave me some problems and stuff. But that's how you do these projects. Define what you want, and it will work with you, and it'll say, connect this to this pin, etc. You can see down here, oh, right here, here's my display. Like that display over there. says I2C 20 by 4 LCD. Here, I'm going to go ahead and copy that because I'm going to use it again. Copy. So I gave it the exact brand and model of the LCD display, and it says on this one here, these are the pins, pin 21 and pin 20, SDA and SCL. And it says right here's the header. Ta-da! And because I'm using two LCD displays, there's one tiny little solder joint in there, two little pads that you solder them together, and that gives one of them a new address. Because in other words, it thinks that they're parallel, it thinks that they're the same display. So you change this one little tiny jumper, and now it knows that this one is LCD1, this one here is LCD2. And on my greenhouse project, one of them has all my sensors, all my temperature and readouts. The other one has got my menu. So I can go in and modify like when to turn my fan on and to go through and create a diagnostics mode to like activate motors and stuff manually instead of waiting for the system. So yeah, I have more than one LCD on one of my projects. Cool stuff. But here, right here, it tells you exactly where to connect it. See this? D22, this is my humidity sensor. Connect it to D22. Follow the instructions, guys. Follow it. Photoresistor, A0. And mind you, it says A0, and you're probably like, how do I connect that? We go into that, folks. Down here, way down here. Let's see. Man, it's way down at the bottom, isn't it? Well, someplace down here at the bottom, I said, how do I wire in this component? And then I say, okay, now how do I wire? Even though it said way up at the top how to wire it in, work step by step. So my light detecting resistor, my LDR, how do I wire this in? And it says connect one side to VCC, and then you have one pin or one side that's going to be pulled up by a resistor, and then the other side has to be connected to the data. So it goes VCC to a resistor to the data line, and then the other side goes to ground. And it showed me with like a little pictogram exactly how to do it. It's crazy. Let's see, are your LDR wired megapins? I said both LEDs are now in parallel. Okay, well you get it. Like you just talk to it and it will work you through the problem, okay? So here's the thing. You can fix something enough with AI that it will start to break. In other words, ChatGPT is lazy, guys. It is lazy. It always takes the path of least resistance, which means sometimes it just won't compile your code. It just won't give you something. And sometimes it's like, I'm just going to give you half the code. So saving, testing, and then trying again, like you typing in a modification, like, no, that didn't work. I want to increase this timer to 5 seconds or whatever. That's a conversation. You just type it in, and then you have it saved in the Arduino environment. Then you post in your new code, and then you test it. And if it crashes, and you're like, go back to the previous one. We're going to do that next. But anyway, I just want you guys to be aware that this is how we discuss the project with the AI, and it will give us the code. And ChatGPT's lazy, guys, so it will only give you part of the code. And right here, I'm scrolling past. All this is the code for my greenhouse project, which is like 1,000 some lines. Okay, and notice right here at the top, it says copy code. So I can copy it, and all this code that's in the grade box right here will be in my clipboard, so I can paste it in the Arduino environment. So what we're going to do is we're going to start a brand new project. Okay, there we go, there we go. All right. So we're going to start a brand new project, and we're going to basically give it this information that obviously it's blacking out crazy on my display. Okay, so we're going to give it this information I wrote down, which is my relay, what pin it's connected to, my PIR, and the Arduino, and then my display, and it's going to give me code, and we're going to run it. Okay, do it. So I'm going to start a new chat. New chat. There we go. Let's see. And I'm just going to tell it what I want to do. I want to. Oh, geez. Help if I can spell. Arduino. Which activates a relay when motion is sensed. I'm using, oh shoot. I'm using an Arduino ESP32 5-volt relay. PIR sensor. And a I2C 20x4 LCD Hoya-san. That is literally the description that I got off the Amazon listing. Right there. It knows exactly what I'm working on. Okay, but now, remember, I said make sure you type it all in or else it's going to make some assumptions. It's going to tell you where to connect those devices, like the PIR sensor and the relay, unless I tell it first that, hey, I've already got it connected. So relay is switched high. So remember there's a little jumper on there that says switch high or low. Relay is switched high and connected to D2. And let's see, PIR. Sure. Connected to D4. Oh, shoot. So, by the way, AI does not care if you have bad spelling. It will figure it out, so don't worry about that. PIR sensor is connected to D4, and I do not know where to connect the I2C display. Okay, I've never run this before. We just did it live. It's going to figure it out. Okay, you ready? There we go. And look at this. It tells me what pins it suggests. Most common default pair is GPIO 21 and 22. Mind you, it says SDA is 21, SCL is 22. SDA is 21. Okay, so let's go ahead and let's go over and let's wire that bad boy up. Here we are. Zoom it in. So it said that SDA is 21 and 22. So right here, SDA is gray. It says gray is 21 and 22. I think I messed up. Hold on. This is good. This is good because now you guys can see. Let's tell it more important data, right? My ESP32 Arduino Nano P32. It thinks I had a different ESP32, guys. All right, here we go. All right, 5-volt ground, ESP32. So it says that it has a LV, SDA, and SCL. I didn't know that. So it says right here on the Nano, these are the pins I should be looking for: LV, SCL, and SDA. Let's go check it out. All right, let's see. LV. What the hell is it talking about? So there's an RX and TX. And I wonder if that is what it is talking about. I don't think it still thinks that I'm doing the correct thing. Okay. Oh, okay. So it is saying right here that it would be best to use a level shifter. Okay. The Nano ESP32 does not have an. Okay. So let's say I don't know where these pins are. So notice is a conversation, guys. Look at this. It pulled up images. How cool is this? Let's check it out. So we have a D0, D1, and pin numbers, nano pin numbers. Okay. So notice that these pins have different numbers. So A7 is also 14. GPIO. On the Nano ESP32, intentionally labeled. No, they're not labeled at all on mine. So here is where ChatGPT fails. And that is probably a good thing. Let's go ahead and copy this. And I'm going to show you a solution. Let's go into Grok. Okay. So this is Grok, guys. And this is Elon Musk's baby. And trust me, some ways it works better. Some ways it seems like it's more irritating. I have had extreme success with it. Let's go ahead. Let's just type it in here. Okay, so we're going to put the same exact information into Grok, and let's see what it says. Trust me, ChatGPT messed up my greenhouse project a lot. And then I put the exact same code, I copied it and pasted it into here as a text document. And it said, here's some suggestions. And I said, go ahead and make all the changes that you suggest. And it kicked out all new code and it just started working. It just started working. So amazing. Okay, wiring instructions. So it tells me about the PIR sensors. Okay. The 5-volt relay, where I need to connect it. Again, step by step, guys. So it says Arduino A4. Hey guys, is it just me? Did ChatGPT not tell me exactly what pin it was? Because the pins are not what I have over here. So it says SDA is Arduino A4. It says SCL is Arduino A5. Well, that's easy. That's way easier for me. Let's go and do it. All right, so it says that A4 is my SDA. And right here, A1, A2, A3, A4, that is not labeled anything else. Let's go ahead and put our power lines in. And then we can connect these. Okay, Okay, so SDA is A4. SDA is gray. It's a good thing this happened on camera because this is stuff that happens all the time. So this one here goes to A5. Boop. This one here goes to A4. Boop. Okay. Let's go ahead and let's see if this guy will power up. And to do that, I've got my variable power supply. Which I know is currently running at 12 volts. So that's why I do not have it connected yet. Yeah. All right, all right. Let's only give it 5 volts. Nah, screw that. Let's give it 8 volts. Okay. Connect this guy right here. Okay, we've got power. And I have nothing on this guy, so I'm questioning my voltage rail right there. This could be the one that's broke. We're gonna find that out together. Says I'm currently sitting at 5 volts. All right, we're gonna go through the process together, folks. So right here's my meter. I'm gonna put it on DC. Let's see if I have any voltage coming out. 6.84 volts. Okay, how about this one? Got nothing on that side. So let's go ahead and remove this jumper. And I already said earlier what I would do if it was broke. We're going to go ahead and we're going to wire it in parallel. So ground to ground. Turn this guy down a little bit. Okay. So I'm currently sitting at 5.21 volts. Go here. There we go. Put this one here. And now let's measure it. Come here. .92 volts. So you are going to use a multimeter when doing this stuff, guys. Be mindful of that. You can see I'm turning it up to 5 volts very slowly. Okay, close enough. All right, so we got our V in right here. Get this guy right here for ground. I think we're ready for this bad boy. And let's see, this guy right here is correctly wired up. Ground black. Ground black. Okay. We should be ready. I'm a little confused at this guy though. It should be powering up right now. Well, we'll figure it out. We don't need any of that to program it. So let's go ahead and let's go into the next step. I'm going to go ahead and shut it off. So I recommend you guys get one of these variable power supplies. Highly suggested. Let's go ahead and let's go back and let's generate some code, folks. Okay, so I have connected everything according to what they say. And it says that I need liquid crystal I2C for the LCD. I'm going to show you guys how to get that. All right, and let's go ahead and let's start a new sketch. So a program for Arduino is called a sketch. You have to get used to that, okay? And this right here is the Arduino IDE. It is free. You can type in Arduino software, Arduino IDE, and you can download this yourself absolutely for free and check it out. So it gives me down here a bunch of code. I didn't write any of this. Y'all seen it? Very simple. This is only like what, 30, 40 lines. We're going to copy that code. We're going to come over to that Arduino IDE. I'm going to highlight everything in there and I'm going to erase it. And let's paste it. Okay. I'm not doing anything else because now what we have to do is we have to connect our Arduino to the computer. All right, let's do it. Okay. I do not even know if their Arduino works. I might have blown this one up. I don't think so, but we're going to find out together. All right. So that tells me I had a problem with my voltage rail someplace. I'll figure that out later. So it's connected with my USB-C. I've got power. You see my display lit up. It was at least happy for a moment. Okay, this guy here might be a problem child. We'll see. Notice I do have multiples. Okay, so now that we're connected, it's showing that it's happy. And now we can go back over to the Arduino IDE and let's put some software in it. Okay. So now we have our software, but we're not completely ready yet. You see, I've got some messages that are coming up saying, hey, by the way, it's saying that we have connected it. You should see something populate right here, like your COM port. Sometimes that doesn't happen. Sometimes you have to manually come in and select things. And that, you have to work through it as you get it. You know, go into Device Manager, plug in your USB, and look for your ports. Let's see. Here's Device Manager. If you guys have ever had to go in here before, hopefully you have. And there's going to be communications ports right here. See this? And you can see I've got COM22 and COM5. So what I do is you stare at that and you unplug the Arduino and you see what COM port disappears and reappears. I know, it's very caveman-like, right? There we go. And it just popped back up right here, COM22. And look at this. My Arduino is also popping up right here under other devices. But right here, this is what we want, the COM22. Okay. So it should populate up here. If it doesn't, then sometimes you got to go in here manually and select your COM port and your Arduino that you have sometimes. I would suggest updating the firmware. Always check that. And let's see. There's another thing that's in here that's pretty cool is the serial monitor. And serial monitor will tell you what's going on your device. But you have to tell the AI, I want to see what's going on the serial, excuse me. I want to see what's going on the serial monitor. Okay, because that's extra code that it has to put in here to print those lines right here. So if it's a button press, if it's something turning on or off, like fans turn on, fans turn off, daylight, nighttime, it will post all that right up and in here. Oh, look at this. And it says, hey, we have new software. Do you want to install it? Normally I'd say yes, but we're not going to do that to you guys. Okay, so I pasted my code in here, right? These right here are the annotations that tell you what's going on with each step of the code. See that? You don't have to really understand it. It's okay. You can go in and tinker if you want to. Like right here, I can say if I want to switch that relay from high to low, I just switch it right here. I can type it in. But I suggest not making changes here. Make changes here. Like go in and tell the AI that didn't work. I want it now to be low instead of high. Because other words, when you continue on, and you will, it's not going to know that you changed that. You want it to be informed on everything you're doing throughout the process. Other words, you're going to be troubleshooting problems that you might not know you have. Okay? So always work with the AI. If you change something, tell the AI what you did. That way there, it stays current on what your project is doing. All right? Ask me how I know. Anyway, let's go back into that environment. So I have my Arduino here, my code down here. You can hit the little guy right here. And notice how it says Arduino ESP not found. Here is how you use the AI for troubleshooting. Copy error messages, come back in here, and paste your error messages right here, and let's see what it says. And look at this. And it's going to tell you exactly how to get it back in. Tools, boards, board manager. Okay, in the boards manager, so let's do what it says. Tools, boards manager, and this was the Arduino ESP32 boards. So we type it in, and look at this. It says, would you like to install it? Yes. And right here, it's installing it down here. That is how you troubleshoot. If it says, hey, this didn't initialize or whatever, copy that error code, paste it into your AI, and it will fix it. And then it will give you, because AIs are lazy, it'll give you, like, here, just insert this code into your thing. Say, no, I want you to regenerate all the code, including your suggestions or your improvements. And it will regenerate the whole code. Don't copy and paste little teeny pieces into your code. Make the AI regenerate all your code. That way there, you're not piecemealing a program together, and AI knows exactly what it gave you. Okay? That's key. All right, so it says processing. Sorry, my voice is going out, guys. Processing Arduino ESP32 boards, yada, yada, yada. You see it's almost done installing right here. Almost done. It's doing it. So here's the cool thing. This IDE, this Arduino Integrated Development Environment, it's so easy. Like, if there's a sensor I didn't have, all you got to do is go up here into like Tools, and let's see, where is it? Manage Libraries. And if I don't have like temperature and humidity sensor or something, you could just go into Manage Libraries, type it in. Temperature sensor. And it will scan for all the different temperature. Look at this. HTS 221. And if you know the exact model of your sensor, which AI will tell you if you take a photo and import it, then you can type that here and you'll get the library for it. Library is like the driver that tells the software how to use the sensor, right? You don't have to know how to do it. You just literally click the install, and then you try to run the code, and it will either run or it won't. And again, you copy the error code and you can paste it into the AI, and it will help you. So let's go ahead and get rid of that. It looks like we are done. Look at this. I can't believe I didn't have ESP32 installed. Sure, of course I want to trust AI or the Arduino. And yes, let's install. You guys are watching it live. I've never done it before. There it is. It says it's installed. Okay, so I posted the error code into the AI right here, and then it told me exactly what I need to do. All right, let's test. Let's see what we can do. Let's verify it. That's the check mark. It says compiling sketch down here. Here it goes. Okay. It says liquid crystal I2C claims to run AVR architecture. If it gives us a problem, we'll copy the error back into the AI and we'll fix it from there. There it goes. Okay, so here is another reason why you might want to choose a different Arduino. There are different sizes of the Arduinos for memory. And like my garden right here would easily run out of memory with the Nano. However, the ESP32s have more memory, so they can handle it. You can see right here, I'm only burning 9% of my program. That's pretty good. That means I have lots of room for improvement. Although that's not a very big program. I have over 1,000 lines of code just for that guy. So if you need a larger Arduino, it might not be for the amount of pins, it might be for the amount of memory. Remember that. Okay, so it says that it's good. Now let's go ahead and upload. You see a little upload thing that popped up right here? We are currently sending the data over here to the Arduino, and you can see it is programming itself. It's doing things. And then when it's programmed, this guy here should have a display. Okay. And it says we're done over there. Cool. I just clicked the reset button just because, not for any particular reason. Okay. And it says no error condition is present, and we are done. So there we have it. I have uploaded the program. It's now over on the Arduino, and now it is ready to do something. Okay? So let's go over. Actually, you know, let's show you how to update it. I want to make a change. All right? Want a splash screen. Let's see, what do I want it to say? Motion relay. Motion relay system. So it's going to say, sure, I can do that. Here it goes. So there we have it. It just spit me out new code. I'm going to click copy. And we're going to go over to the Arduino environment. And I'm going to select everything. Edit, select all. Go ahead and erase it. And now our code is 79 lines. There we have it. And I'm just going to send it. It says liquid crystal I2C claims to run AVR architecture may be incompatible. So if we don't get a display, it's basically saying, here there could be a problem. I like that little download meter right there. That's cool. Okay, we're ready. Let's go back over and let's check it out. Okay, so at this point, the program is on the Nano, so we can disconnect the USB. All right, we don't need it. and it's not booting up. So let's go ahead and let's figure this out together. Let's get rid of this guy. Let's get rid of this guy. And let's see. I got this one right here. This one here. Let's see if this one's better. One of these was bad. I know it was. Okay, we're at 6 point something volts. Okay, and mind you, oh yeah, I did. I took the wires away for this guy. So V in, go here, ground. To here. Okay. Make sure my rails are correct. I'm sitting at 6.23 volts. All right, what am I doing wrong? That is definitely V in. That is ground. All right, let's check it with the meter again, guys. Minus and plus. 4.46 volts. It's almost doable. 4.46 volts. Let's pull this bad boy out. Okay. Come on. Okay. So, shooting a little bit low. So let's go ahead and increase this a little bit. Come on. 5.03. There we go. You have to have over 7 volts coming into the DC jack. Okay, we got it. So positive, negative here. A4, A5, those look like they're all connected correctly. It should be powering up, but it does not want to. Okay. Let's see if we can force it. So I also have some of these battery banks we can also power it with. I don't think I broke this guy, because I've got a bunch of different ones that might be broke, might not. It should be lighting up, which tells me I'm not doing something right. Let's put this guy here on 3.3 volts. And let's switch my V in to the 3.3 volt header. And that means that my display here has got to be powered from this side. There we go. Okay, so there was a problem with this rail. Sometimes the breadboards are defective as well. So remember that, guys. You can never trust these breadboards. All right, well, let's try switching to ground. Yeah, I appear to have a problem with my rail. As soon as I switched over to here, you see how it lit up. Okay. Let's wire it from that side. V in to over here. Okay. I don't know what's going on with that V in pin. It should definitely be lighting up. What the? Okay, so I know I got my voltage on that rail. You can also power it via the USB, which I can. Let's see if this works. don't know if the ESP is going to like this. It does like it. Okay. You can see the little status light flickering away, doing some stuff. So this breadboard's clearly got some sort of issues going on over here. But that's all right. You see, we do have power over here on this guy, and this guy right here allows me to adjust the contrast of the display. And I didn't really tell it what to do on the display. Anyway, don't expect these wires to be quality. Something's going on with this breadboard. You can take it apart from the back and check that out. But that or something's going on with my Arduino. However, let's go ahead and show you guys my more complex projects so we can talk about how I solve some problems. Okay, let's do this. So this guy right here, this is an Arduino Uno, just or a Nano, just a little guy right there. And I've got a lot of stuff. This is all extra. These were all for troubleshooting and whatnot. Because what I wanted to do is I wanted to run this guy off of like a battery bank. And it just was not able to do it. It was very frustrating. And that's because it uses so little power when it's in its dormant phase that these battery banks were shutting off, like all of them. And I've got a bunch of these different battery banks. And they were just shutting off because if they don't detect a certain amount of load, then it was creating a problem. So I said, all right, what I want to do is create a load bank. And my load bank is just going to chirp just a little bit of load on these resistors, just enough, like every 5 seconds, to keep this guy awake. Here, it's in sleep mode right now. See, now it's awake. So if the battery goes to sleep, then this guy shuts off. Not good. So this guy right here, I've got a relay, I've got a PIR sensor, I've got a light sensor right here, and now I've got my 3 LEDs right here. And what happens, you can see it running the program. This guy here sits in my bathroom, and oh, it smells so good too. So I've got a fan up and under here, and I've got essential oils and stuff in here. And bathrooms are a unique place because there's usually not electrical outlets. So guys like this generally don't work because there's no place to plug them in. And then we got products like this guy right here. Genius product. It diffuses oil using a ultrasonic diffuser right there, vaporizes it as a mist. But the problem is this guy will continue running day or night. And you don't want the damn thing running when you're not in there. Let's say you're not even home. It's going to continue wasting product, and that's how they get you. By design, it's simple, but by design, it also is a very wasteful product. So I wanted to build a prototype of something that detects when you're walking into the bathroom. Before you even get to the room that's got the toilet, it clicks on, and this guy sits above the toilet on the cabinetry, and it runs off of 3 AA batteries that you can see right here. And all this guy's doing is pulling this infrared sensor right here. And when it senses motion, it says, okay, click on the fan. And if it's nighttime, it clicks on the LEDs. See that? So it knows the amount of light going in the room because of the LDR right there. And if it's nighttime, it clicks on these 3 little LEDs, which you would be surprised at how bright those tiny little LEDs are when the bathroom is pitch black. So I don't even have to touch a light switch or anything. It clicks on enough light where I can clearly see what's going on, and it clicks on the fan before I even get close to the toilet. So everything smells fantastic, and I can see what I'm doing in the middle of the night. Wouldn't it be just so simple if we could buy a product like that in a format like this? I wish. So this is just a prototype. It looks really rough. This is a soldered in board. I do not have a breadboard for this particular one. It started as a breadboard, and I was like, nah, this is so simple, I'll just solder it out. And that's what I did. I do have risers on this, nano right here. So I can take the chip off. You can see I can raise it and I can lower it. So if this guy ever gets defective, I can just raise it off, pop a new one on, and I'm good to go. I did have one little problem. I have an electrolytic capacitor that popped off someplace. I have no idea where it came from. And in the end, who cares? Who cares? I might have had it to stabilize some of the voltages or something. I don't know. Wherever it's coming for, who cares? So I've got my little relay right here. And this guy right here was pulsing. Or no, it actually activates the fan. So this guy clicks on or off. And this one is a 3-volt relay. So it just shut off there. And if I do movement, it refreshes it. So I put timeout cycles on this. So it'll only run the fan for 30 seconds when it senses motion. And after 30 seconds, it waits like 60 seconds, and then it checks again for motion. And these LEDs right here, they will run for 5 minutes. So when it senses motion and it's nighttime, they will activate for 5 minutes, okay? Or when the lights turn on, they shut off. So you'll actually see them shut off in a moment because I took my hand away and it sensed, okay, somebody must have turned the lights on. There you have it. All right, guys, so that's that project. That is a very simple one. So there's 2 of the projects. Now, I did a video a long time ago on a vacuum machine that I got, and I think I even did a live stream on it. Anyway, the vacuum sealer, the computer chip that runs it was bad, but the pump, the solenoids, all that, the sealing bar, all that was beautiful. It was in fantastic condition. It just needed to know what to do when, and it needed to know the pinout for the little control panel. And first thing I did, put my multimeter in resistance mode, find the pinout. All right, you press a button, you see what pins on the ribbon cable are shorted, then you press the next one, find out what 2 pins are shorted, and then the next one, okay? So you find the pinout, and then again, you can feed that into the system, and now you know the start button is pin 4 and pin 1, right? So it knows that when pin 1 is shorted, that it's going to start the machine. And if you press it a second time, you stop the cycle, right? So instead of throwing out this vacuum sealer, which is well over $1,000, I was able to preserve it, and it's in use right now. It's being powered by a little nano chip, like that little bathroom buddy that I made. The exact same system. That's what's powering it. And it works beautifully. I have my electric garden right here. So I'm gonna clear off the desk over there, and I'm gonna move the garden over. I'm gonna show you what's going on in that, because that was the most complex one I've ever built. And believe it or not, when I switched my code, so let's go ahead and show you that. Oh man, the code was a little bit of drama, and that's because ChatGPT is lazy. All right. So if you learn anything in this, ChatGPT is lazy. Okay. Let's get rid of that. I don't want to save my sketch. Don't save. All right, so let's see. ChatGPT project greenhouse. Okay, so what I ended up doing is I told ChatGPT, because it started messing up, I told it to give me a complete pinout, okay, which you can see right here. I was frustrated, I was done, I was pissed off. And I said, I want a text document with complete pinout and functional description of the smart garden. And it does this very well. It gave me all the pinouts right here. Tells me what pin's connected to what. And then down below, it gives me a functional description of what the machine is doing right here. And what I did is I took all that info and I imported it directly in over here on Grok, and it just did it. All right, look at this. I put the exact same thing right here. Oh, actually, that's today. Smart garden. There it is. Yeah, this is kind of a big one because it's well over 1,000 lines of code. All right. So I said, can you improve on this code? And then I took the text document of the old code, because it was pretty good. It kept messing up. And then I imported it, and then I had the pinout and the functional description. I imported those, and it just spit me out code that started working. Grok did awesome. Look at this. But Grok was a little bit lazy too. It only gave me like 480 lines of code. It said, we can do the rest later. And I said, no, I want all the code, all of it. Compile all the code with all your suggested improvements. And when I did that, it generated all the code. And then my system started working beautifully. And it did one thing I wasn't expecting. It created, I've got a switch on the front that wasn't going to anything, and it created a pin for the automation of my greenhouse. It created a pin or a switch to turn it on and turn off automation. Why would I ever shut it off? But it's kind of cool, I guess. So my system wasn't working, and I was getting all pissed off. And then it said, make sure that the switch is closed. It had me type out exactly what I'm seeing on my LCD display. And it said, your system is off. It's not in automation mode. Make sure the switch on pin D39 is grounded. Make sure it's off, or make sure it's on. I was like, what? D39 had nothing going to it. After working with this stuff for like a couple days, you kind of memorize this stuff. Well, coming to find out, it created a switch for D39, and as soon as it knew what my display was saying, it told me, like, hey, connect something to this pin, to which I've got a push on-off button, a latching power switch on the front panel that wasn't doing anything. I was going to use it for maybe auxiliary fans or something like that to help cool down the greenhouse. But I was like, hey, this little switch isn't going to anything, so let's wire it to D39. And I clicked it on, and all of a sudden motors started moving, and like I've got my float sensors and my pumps are kicking on and stuff. I was like, what the hell? So Grok figured it out. It did awesome. Let's go ahead and switch you guys over to the table. I'm going to open this guy up and let you see what's going on inside in a more advanced project. And mind you, this isn't nice, neat, and tidy. I do a lot of stuff with hot glue to hold pins down and stuff, because the beauty behind hot glue, it's an insulator, it's an adhesive, so pins that I don't want to move, it holds the pins there. It's an insulator, so it doesn't conduct electricity, and it keeps pins separated that might be close. And there is undo. I have a hot air station right here, and if I have a problem, which I've only had to do a couple times, I can heat up the glue and pull the wires back out. It's that simple. Soldering and desoldering is a much bigger pain in the ass. So Hot glue works fantastic for these projects, especially when working with breadboards, because I would rather just get a breadboard so that it's working and then glue it down and close it up. Who cares? As long as the pins aren't going to move around, I got a good connection. Let's do it. All right, let's check out the table. Okay, I do have quite the mess over here. Let's go ahead and straighten this up. So today was, I know it was a lot of information, guys, but just remember that the AI is your absolute friend when it comes to troubleshooting this stuff. And use it. For God's sakes, use it. Take photos. I have my phone. I have AI on my phone like Grok or ChatGPT. I'll be snapping photos to the same chat that my computer, that's right here. I got a giant computer in front of me. I will have photos being imported into the same chat I'm looking at right here on this display, because you can have more than one device working on the same chat. So like this guy right here, I can take a photo of the pins and it will tell me, check this pin right here, go down here, check this jumper. It'll walk you through it step by step. It does phenomenal. AI is your absolute friend when it comes to troubleshooting, guys. All right, let's get some of this out of the way because this project is big. It is big, folks. All right, I don't need this one. And my next project is going to be running at 12 volts. So let's go ahead and turn this guy up. All right, 12, 12.2, close enough. All right, let's move this over, the wires. Okay, and let's get this project out of the way. All right, and let's zoom you guys out so y'all can see exactly what's going on. Okay, and let's see, let's move you down here. All right. You can see right here, I got 3 different wireless AC switch ports. I've got fan, I've got my condensate, and I've got my watering reservoir, or my watering pump. Over here, this is my water reservoir. So this guy right here, this guy is going to be full of water, and there is a little float switch right there. And this guy here, the float switch will fall down when the water goes down. So it will give me an alarm and it will tell me that, hey, my water is low. So this allows me to control the amount of water I have. It allows me to check the pH of the water. It allows me to do things like add a certain amount of growth hormone or whatever it is that I need. Gives me a lot of versatility. And this right here is my condensate bucket. So it's a hydroponic system. So my buckets, which I got a bunch of them, I've got these baskets, and it's going to be full of clay in the plants, and there's a ring that shoots fluids around the plant. Okay, it sits kind of like this. There's little holes all around it. So it's going to be wetting down all these little clay balls that are in there. Keep them nice and moist. And it's going to be doing that at certain intervals. So that's really the key to it. Is this is going to sit in a series of buckets that I have so that I can also allow the plants to grow bigger and whatnot. But this bucket, all of them are going to drain into this one, because this guy here is much easier to move around than my giant water reservoir. So that's where the plants grow. And the bucket has got holes in the bottom that drain into this one. So I've got 8 buckets that when they water, they're going to drain into this guy. This is my condensate bucket. And this right here is a float switch. And when the condensate fills up to here, it's going to lift this guy up. This is a magnetic Hall effect sensor. And when it comes up, it breaks the signal, and it turns on the condensate pump, which is going to activate this guy right here, and it's going to pump fluids from this bucket into my master water reservoir, which could be a distance away. It could be. I'll figure that out later. So that's how the system works. So this is all my wiring for the buckets. This guy right here is a gear reduction motor, and this one is going to open and close the doors or the windows on my greenhouse via a cable and pulley system. It's very strong, operates on 12 volts, and it's going to lift up 2 windows at the same time. So at nighttime, it's going to lower the windows, and in the daytime, when the temperature is within a certain range, it's going to raise the windows. Right here is my temperature humidity sensor. Ta-da! All wired in. Here, let's carefully place this stuff back in here, because you guys don't really need to see that stuff. And here is the garden. So this is the controller. This is the little button I was telling you guys about. It's a push on, push off. This button right here was going to be an auxiliary for fans, but that's now my automation for the whole system. I have a big blue momentary button. The momentary button is for instant watering. So let's say I ran out of water, or let's say I'm changing out my fluids or something. I can do an instant water instead of waiting for the system to reach that next cycle, which is 5 minutes, 10 minutes, 30 minutes, whatever I set it as. I can do an instant water, and all the plants will get 5 minutes, 10 minutes, 30 minutes. I can set how long it's going to run once that button's pressed. And here's my on-off button. Up at the top, I've got my LDR, my light detecting resistor. I've got a flashing red error light, and I've got a green power light. This is my 12 volts coming in. And I have a splash screen when it boots up. There we go. And now, as soon as it boots up, my motor starts running, because notice it says day. If it's daytime within a certain temperature range, it's supposed to open the windows, right? And I'm going to cover the LDR sensor. You can see the LDR right there. See it falling? It switches to nighttime. And look at it. It's closing the windows because it thinks it's nighttime. There we go. Okay. And now it's going back to daytime. We could do this all day, guys. All right. So right now, my shop is not the warmest thing in the world at 63.1 degrees. But the way I have it currently set up is when the temperature for this guy right here gets 82 degrees, it's supposed to kick on the cooling fan, right? And with the condensate, this is this guy right here, if it detects that it's full, it kicks on the condensate. You see that? And it's supposed to run for like 30 seconds afterwards, because that's not the bottom of the bucket. It wants to continue draining for 30 seconds. And then this guy will automatically shut off. Okay. Now, some of the other things that I do is over here in the water detect sensor, if that one is down, like this guy runs out of water, it will not allow the water pump to run, because the worst thing you can do is run an empty water pump. It will blow the pump up. So it will give me an alarm right here if this sensor goes down. And I've got tape on it. And it also alarms when the water runs out, so that we all know. So there, I restored it, goes back to normal condition. And And down here, it gives me a status. So it says reservoir okay, and my condensate is okay. Mind you, this was all designed with AI. I did not do a single line of programming for none of this. Let's go ahead and run my watering pumps. Instant. So here we go. It's running. And remember, this guy also has a temperature sensor, which is here someplace. Where is my temperature sensor? There's that one. There's that one. There's that one. All right, well, it's here someplace, right, guys? What did I do with it? 1, 2, 3, 4. Ah, I'm such a goober. I put it on top of it. There it is. Okay. Now you can watch my temperature and humidity. Remember, it has to get to 82. Take a look at that. Now, I do need to change the code on here. I need to add some hysteresis. So hysteresis is something that you'll learn about and the AI will tell you about. Let's say it's at 82 degrees and it's evening or it's morning, and it kicks the fan on, cools the sensor down, shuts the fan off. And it's sitting right there, teetering right on the level. You want it to run for a certain period of time and then shut off. Because right now there's no built-in hysteresis. So if it's right at 81, 82 degrees, this fan could be clicking on, clicking off, clicking on, clicking off. That is not a good thing. So you got to add in some hysteresis. So I still have to add another version of software on this guy. But I'm so happy that it's just working as we speak. So let's go ahead and take a look at the menus. That's all operated through this control panel right here. So the menus allow me to go in and like set dip switches to turn on. Like I can turn on these guys, etc. So pump on. C and D is for navigation, A is for selecting. So I can set how long I want my pumps to run on. Cancel. And this guy's got, let's see. This guy's got a little bit of a goofy software. So my control panel right here, one of my pins is low, so my bottom buttons right here is not working. That's all right, we can fix that. Let's open it up and I'll show you guys what it looks like on the inside. Never want to open one of these guys up when it's got power. So let's go ahead and place the stuff back down. Now mind you, this is not going to be neat and tidy inside this box. It's going to be organized so I can troubleshoot it, but it is not like a develop project where like everything's beautiful. It's a prototype, and it's a prototype that works. Oh, by the way, my water kicks on for a certain period of time. That's another option settable in the menu. Okay. So here's what it looks like inside my smart garden. All right. I think I can lay it down. There we go. So here's the back of my LCD panels. And right here is my Omega 2560. I've got multiple buck converters because remember they're 3 amps each. Way more than I needed. I could have paralleled them up, but I decided I've got them. Let's use them. So I've got this guy down here specifically set for 5 volts only for this guy. So no matter if a relay or something sags on voltage, this guy is always going to have his power. I've got a 12-volt bus bar that comes in, so I can easily divide up my voltages. I can feed 12 volts to this or 12 volts to that, and you can see in parallel I've got my motor for the dual pole dual throw relay, and my wires are going like this, so that when it activates, it's driving one direction, and when it activates the other way, it's driving the opposite direction. but that means the motor would always be running, because to get a DC motor to run that direction and that direction, you need something called an H-bridge, which means it's basically like that, where the lines are switched in like an X pattern. We can do it with a dual pole, dual throw relay, but we need an enable relay. So my positive, it has to click this guy without switching this one, and the motor's gonna run one direction. And then it's gonna click this guy, and now the motor's gonna switch polarity and run the opposite direction. That's how it's set up. Now, one of the most genius things about this is this guy right here. This was the piece that controlled these. And it's empty. You can see it right here. That's the board. And on the reverse, there was a 2032 battery. So I have the 3 volts coming in from its own buck converter. And that's powering it. And then to short these guys, you can see the leads are soldered. It's real fine detail. They're soldered, and then they run up here. And then from here, they run over to my Arduino. So I have this midpoint so I can troubleshoot, to which it worked out like a charm. So there you have it. I've got 3 buck converters, one here. That one's powering my 3-volt rail. I've got a buck converter here. And this is powering this rail. Oh, wait. No, I got 3 volts, 5 volts, and 5 volts. So one of them's powering these devices. One of them is only powering this guy, and one of them's powering only that board. So that's why I've got 3 different buck converters. I could have done it with 2. But there you have it. You can see the breadboard. I fastened it straight in there. I can still build on it, which is kind of cool with just sacrificing the breadboard and saying it's part of this project. I can still build on it. I can still expand on this project with minimal effort. I have lots of real estate. My cabling is maybe not the neatest, but I waterproofed it as well. You can see I got glue on every single entry point except for the gland right here. So yeah, I was able to switch these guys using the remote control, which I wired into my Arduino. AI did help me with that, but I already kind of knew what I was going to do. And notice how I left the pads open right here. They're all open. This one's almost all the way covered, but I can still get in there with a flat blade screwdriver, because you want to troubleshoot these guys without this, right? And basically, you're troubleshooting the buck converter and this guy by just shorting them manually. And if they're turning on and off, okay, that section works. Then right here, now try it with ground to each of these wires. And if it works, then this section's good. Now I only have to troubleshoot this guy, right? So you segment off how you build things so that you can troubleshoot it. And anyway, that guy there is absolutely working. Now, one of the things I told you guys is that one of the lines from my control panel right here was not working so well. That's because some of these wires, you know, they're just Chinesium wires. Sometimes they don't have a really good connection. But that's an easy fix. All I got to do is heat it up a little bit with a hot air station and then push the wires closer together. But that's it. That's my smart garden, and it works an absolute treat. And it's being fed off of, basically based around these wireless Harbor Freight switchable 120 volt outlets. And how cool is that? It's an off-the-shelf part. If I need more, I can just go back and get more of these. You know, it's something that they've been on the market for years, so I could have a whole second section of them, and easy to troubleshoot. So this is all low voltage in here, especially since it's being powered by a DC power supply. And all my high voltage or AC power is separate. So there's no need for me to have a GFCI here. I've got a GFCI power strip for these guys. But this guy here is all low voltage, so it's going to be in the greenhouse. It's going to be much safer. So there you have it, guys. So there it is. It's I know it's kind of crazy. It was a lot of information. My voice is almost completely shot, so I'm gonna have to stop talking. But that is pretty much the process of building out a project from the beginning, designing it, going into the AI, telling it how you want to do what you want to do, make sure that it's all kind of written out when you first send the message. If you just say, hey, I want to add a button, I want to add a relay, it's going to eventually mess up. Give it a story right in the beginning that says what you want the object to do, what components you have, and allow it to build out code. And then you import it, run the code. Does it work? Go into regular troubleshooting, because there's no way it's going to work the first time. Nothing ever does, right? So go in, test it out, and then work up from there, okay? So I've got, I don't know, probably 5 or 6 different projects here that have been beautiful. They work great. And I want you guys to go out there and just think about that. Like, there's nothing that we can't do anymore. I've got a coffee pot in the house. It's a Philips coffee pot. And if that CPU ever breaks, I still have buttons, I still have a pump that works, I still have a heating element that works. There's nothing I can't do with an Arduino and maybe a MOSFET for switching. I will convert that thing over to an Arduino touchscreen. I will do it. So, guys, if something breaks, I want you to think that from now on, it's not really broken. What if, right? And there's a lot of processes, maybe something that you put up with that's been pissing you off. You don't have to just put up with stuff. Now you are part of the creation process. Go out there, you have an idea, you've got something that's been giving you problems. I don't have 120 volt electrical in my bathroom, so what did I do? I create some sort of monstrosity that took me a day to make, but it works a treat. It works. So it is how it is, man. So guys, if you have any questions going forward, obviously you should always first ask the AI, because AIs are changing, they're always getting smarter. But if you are interested, go ahead and write me, justin@betterbiomed.com, and tell me your concept for what you'd like to do with Arduino. And maybe I can get you some pointers, because I've run into some hard stops before, and I've had some really good successes. So think about that. I'm here to help you guys. We're all still a community, and I'd love to hear what ideas you guys have for Arduino and electronics going forward. Thanks for watching, you guys. My voice is absolutely garbage right now, so I'm gonna have to stop the stream, but go ahead and write me and let me know what you guys think. And I would like to thank all of you guys that are watching. I hope you guys learned something, because I know I learned a lot the last 6 months on microcontrollers and electronics in general. Just getting your hands dirty and going out and doing it, all right? So thanks, guys. Stay warm out there and have a fantastic day, all right?